Imagine a place of absolute, unending darkness. It is a world sealed away from our own, buried beneath an immense ceiling of solid ice. This is not some distant planet, but a realm that exists right here on Earth, deep within the Antarctic continent. For millennia, this hidden space has remained untouched and unseen, locked in a cold, silent embrace. Scientists long believed that nothing could possibly survive in such an extreme environment. The pressure from the ice above is crushing, the temperatures are perpetually at or below freezing, and there is no sunlight to provide energy for life as we know it. It was thought to be a sterile, lifeless void, a final frontier of biological impossibility on our planet. Yet, life, in its astonishing resilience, has found a way. Recently, a team of researchers drilled through 500 meters of the Filchner-Ronne ice shelf. They lowered a camera into the borehole, expecting to see nothing but the muddy sea floor. Instead, they were greeted by an extraordinary sight. There, in the ink-black water, were small shrimp-like creatures, known as amphipods. They were drifting gracefully in the currents, completely at home, in a world that should have been utterly barren. This discovery was a profound revelation. It challenged everything we thought we knew about the limits of life, and opened up an entirely new chapter in our understanding of the planet. These tiny animals are living proof that even in the most hostile conditions imaginable, ecosystems can emerge and endure. They are not merely surviving, they are part of a community we have only just glimpsed. The creatures were found on a boulder far from any known source of food. How do they feed? What do they eat? Do they rely on chemical energy seeping from the seabed, or do they consume nutrients that have drifted for hundreds of kilometers from the open ocean? These questions remain unanswered for now. Their existence hints at a vast, interconnected web of life that has been thriving in secret, right under our feet. The discovery forces us to reconsider the entirety of the subglacial environment. If life can persist here, in this one isolated spot, where else might it be found? Antarctica's ice sheet covers an area of almost 14 million square kilometers, and in some places, it is nearly 5 kilometers thick. Beneath this colossal shield of ice lie countless other hidden spaces, caverns, rivers, and lakes that have been sealed off from the outside world for millions of years. Each one is a potential lost world, a biological island that may have evolved unique forms of life in complete isolation. The story of Antarctica is no longer just one of ice and cold, but one of mystery, discovery, and the indomitable power of life. From space, Antarctica appears as a vast, serene expanse of white. It is a continent of superlatives, a land of extremes that dwarfs our human scale. Its sheer size is difficult to comprehend. It is larger than the United States and Mexico combined, a colossal landmass centered on the South Pole. This is the coldest place on Earth, where temperatures have been recorded plummeting to an almost unimaginable -89.2 degrees Celsius. It is also the windiest, with ferocious katabatic winds that cascade down from the high interior plateau, sometimes reaching speeds of over 300 kilometers per hour. It is a formidable and unforgiving environment. Despite these harsh conditions, the continent holds a resource of immense global importance. The Antarctic ice sheet contains approximately 90% of the world's ice and, astonishingly, about 70% of all the fresh water on our planet. This vast reservoir is locked away, in a frozen state, a silent guardian of Earth's water balance. If all of this ice were to melt, global sea levels would rise by a catastrophic 60 meters, inundating coastal cities and reshaping the geography of our world. The stability of this great white continent is therefore not a remote academic concern. It is directly linked to the future of human civilization across the globe. This frozen world, however, is not as empty as it looks. While life on the surface is sparse, largely confined to hardy lichens, mosses, and resilient coastal animals like penguins and seals, the world beneath the ice is proving to be surprisingly dynamic. Scientists are discovering a complex and active landscape hidden from view. There are vast mountain ranges, such as the Gamburtsev Mountains, which are as large as the European Alps but are buried under kilometers of ice. There are also active volcanoes, their heat melting the base of the ice sheet from below, creating a network of hidden caves and liquid water channels. The future of this continent is also a matter of intense international interest. Under the Antarctic Treaty, the continent is designated as a scientific preserve, a place for peace and cooperation. But this treaty is scheduled for review in 2048. Nations like China and Russia are actively expanding their presence, building new research stations and conducting extensive surveys. They are mapping the land, assessing its potential resources, and securing a strategic foothold. The competition for influence in this remote and challenging land is quietly intensifying as the world begins to recognize the immense scientific and geopolitical value locked within Antarctica's icy embrace. The Antarctic ice sheet is more than just a massive body of frozen water. It is a meticulously preserved archive of our planet's past. Each year, new layers of snow fall upon the continent, compacting the layers beneath them under their ever-increasing weight. Over thousands and thousands of years, this snow is compressed into dense glacial ice. As this process unfolds, tiny pockets of the atmosphere are trapped within the ice. These are not just empty spaces. They are perfect, microscopic bubbles of ancient air preserved like insects in amber. They are time capsules containing a direct sample of Earth's atmosphere from the moment they were sealed away. By drilling deep into the ice, scientists can extract long cylinders of this frozen history, known as ice cores. Some of these cores extend down for more than 3 kilometers, taking us back in time by an astonishing 800,000 years. Each layer of the core represents a specific period in Earth's climatic history, with the deepest layers holding the oldest secrets. Analyzing these cores is like reading a book written in a language of ice and air. Scientists can carefully melt sections of the ice in a vacuum, releasing the trapped air bubbles and analyzing their chemical composition. This allows them to measure the precise levels of greenhouse gases, like carbon dioxide and methane, that were present in the atmosphere centuries or millennia ago. This remarkable record has provided us with undeniable evidence of how our planet's climate has changed over time. The ice cores reveal the natural cycles of ice ages and warmer interglacial periods. Crucially, they also show that the concentration of carbon dioxide in the atmosphere today is higher than it has been at any point in the last 800,000 years. This library of ice provides a stark and unambiguous baseline against which we can measure the impact of human activity on the global climate. It is a silent witness, offering a clear and powerful testament to the unprecedented changes our planet is currently undergoing. The information gathered from these ice cores is vital for predicting our future. By understanding the intricate relationship between atmospheric gases and global temperature in the past, climate models can be refined to provide more accurate forecasts of what lies ahead. The ice, therefore, does not just tell us about our history, it provides a crucial warning and a guide for the future. The secrets held within these ancient bubbles of air are not merely scientific curiosities, they are essential knowledge for navigating the challenges of a changing world, offering lessons written in ice that we would be wise to heed. Antarctica's surface is a landscape of surprising and dramatic contrasts. In some areas known as blue ice fields, the continent reveals its ancient heart. Here, powerful and relentless winds act like a giant sculptor, scouring the surface day after day, year after year. These winds are so strong that they strip away all the new fallen snow, preventing it from accumulating. Instead, the old dense glacial ice from deep below is exposed to the sunlight. This ice has been compressed for so long that nearly all the air bubbles have been squeezed out, allowing light to penetrate deep within it. The result is a breathtaking spectacle of deep, sapphire blue ice that stretches across the landscape like a frozen sea. In stark contrast to these windswept plains, there are other regions where the snow never stops falling and the wind is calm. In these zones of high accumulation, anything left on the surface is slowly but surely buried. History becomes frozen and preserved beneath a deepening blanket of white. One poignant example is the wreckage of a Lockheed P-3 Orion aircraft that crashed on the continent in 1960. For decades, the lost plane was a ghost, its location a mystery. But through the use of ice-penetrating radar, scientists have now located its remains. It lies entombed more than 10 meters beneath the snow, a silent monument being slowly drawn deeper into the ice sheet, perfectly preserved in the frigid stillness. Perhaps the most astonishing feature of this frozen land is the presence of fire beneath the ice. Mount Erebus, one of the most active volcanoes on Earth, rises nearly 4 kilometers above the Ross Sea. Its summit crater contains a persistent lake of molten lava, a fiery heart in a world of cold. The heat from this volcanic giant works its way through the rock, warming the surrounding ice from below. This geothermal energy has created a labyrinth of caves and tunnels beneath the glaciers on its flanks. These are not ordinary caves. They are steam-hollowed chambers where the air temperature can be relatively balmy, creating an environment unlike any other on the planet. Within these volcanically heated ice caves, scientists have made discoveries that sound like science fiction. Sheltered from the extreme cold outside, unique and fragile ecosystems have taken hold. Mosses and algae, powered by the faint light that filters through the ice ceiling, form delicate green gardens. But the most tantalizing discovery is the DNA found in the soil samples. Much of it does not match any known species on Earth. These mysterious genetic sequences suggest that these warm, hidden grottos may be home to organisms that are entirely new to science, life forms that have evolved in complete isolation, shaped by the extraordinary interplay of volcanic fire and ancient ice. Antarctica is not a single uniform block of ice. It is, in fact, a continent of two distinct and very different halves, separated by the great Transantarctic Mountains. These two regions, West Antarctica and East Antarctica, behave in profoundly different ways, and understanding their contrasting dynamics is crucial to predicting the future of the entire continent and, indeed, the world. The West Antarctic Ice Sheet is the smaller and more vulnerable of the two. Much of its base rests on bedrock that lies far below sea level, making it inherently unstable. This marine-based ice sheet is like a castle built on sand, exposed to the warming waters of the surrounding ocean. In recent decades, scientists have observed alarming changes in West Antarctica. The ocean currents, particularly in the Amundsen Sea, have been warming, and this warmer water is now circulating beneath the floating ice shelves that fringe the continent. These ice shelves act like giant plugs, holding back the vast glaciers that flow from the interior. As the warm water melts them from below, these shelves are thinning and weakening at a terrifying rate. Glaciers like the Thwaites and Pine Island Glacier, which together hold back enough ice to raise global sea levels by more than a meter, have begun to accelerate their flow towards the sea. West Antarctica is losing ice, and the rate of loss is increasing. On the other side of the mountains lies East Antarctica. This is the ancient, colossal heart of the continent. The East Antarctic Ice Sheet is far larger, thicker, and colder than its western counterpart. It rests almost entirely on land that is above sea level, making it more stable and less susceptible to the immediate threat of warming ocean waters. In fact, some parts of the high, cold interior of East Antarctica have actually seen an increase in snowfall in recent years. This has led some to suggest that the ice sheet here might be growing, partially offsetting the losses from the west. The situation, however, is far from simple. The fate of Antarctica may well be decided in the compressed zone where these two great ice sheets meet. The boundary between the rapidly changing west and the more stable east is a region of immense scientific interest. How will the acceleration of glaciers in the west affect the colossal ice mass to the east? Could a collapse in the west destabilize parts of the east? Understanding the complex interactions between these two vastly different ice regimes is one of the most urgent challenges facing climate science today. The balance of this divided continent holds profound implications for the future of our coastlines and the stability of our global climate. Beneath the serene frozen surface of Antarctica lies a world in constant, hidden motion. For a long time, it was assumed that the base of the ice sheet was frozen solid to the bedrock below. We now know that this is not the case. The immense pressure of the ice above, combined with the subtle, geothermal heat radiating from the Earth's crust, creates a thin layer of liquid water at the boundary between ice and rock. This water acts as a lubricant, allowing the colossal glaciers to slide more easily towards the sea. But it does more than that. It forms a vast and dynamic plumbing system, a network of rivers and lakes that is completely hidden from our view. This subglacial water system is staggering in its scale. Scientists have so far identified over 400 lakes buried beneath the Antarctic ice. The largest of these, Lake Vostok, is one of the biggest lakes on Earth. It is roughly the size of Lake Ontario in North America, but is buried under nearly 4 kilometers of solid ice. It has been sealed off from the outside world for at least 15 million years, making it a pristine environment that could potentially harbor life forms that have evolved in utter isolation. These lakes are not static pools. They are connected by a network of rivers, some of which are hundreds of kilometers long, flowing in the perpetual darkness. The movement of water through this hidden system can be surprisingly dramatic. Using satellite data, scientists have observed entire subglacial lakes draining in a matter of months, sending huge pulses of water through the river networks. This water can travel for hundreds of kilometers before collecting in another basin, causing the ice surface kilometers above to rise and fall by several meters. These sudden movements can significantly affect the speed of the glaciers flowing overhead. A sudden flood of water can lubricate the glacier's base, causing it to surge forward, while the draining of a lake can cause it to slow down. This hidden hydrology is a critical, yet poorly understood factor in the overall stability of the ice sheet. These rivers and lakes also play a vital role in transporting nutrients and sediments across the continent, all beneath the ice. They carry material from the rocky interior all the way to the Southern Ocean. This process could deliver essential nutrients, like iron, to the coastal waters, potentially fertilizing plankton blooms that form the base of the marine food web. The discovery of this vast, active water system has completely transformed our understanding of Antarctica. The continent is not a static, frozen monolith, it is a living, breathing system with a hidden circulatory network that influences everything from the speed of its glaciers to the biology of the surrounding ocean. The scale of our ignorance about subglacial Antarctica is almost as vast as the continent itself. Despite decades of research, we have only just begun to scratch the surface, or rather, what lies beneath it. The area of the seafloor that has been directly visited and sampled, beneath the ice shelves, is minuscule, equivalent to the size of a tennis court. Everything we know about the vast majority of this hidden realm has been pieced together through indirect methods, using technology to peer through the ice from above. It is a world that humanity has mapped with sensors, but has barely touched with its own hands. To explore this inaccessible world, scientists have become pioneers of remote sensing. They fly in helicopters and airplanes equipped with sophisticated instruments that can see through the ice. Ice-penetrating radar sends radio waves deep into the ice sheet, bouncing off the bedrock below to create detailed maps of the hidden topography. Gravimeters measure subtle changes in gravity, revealing the density of the rock and hinting at the presence of buried mountains or deep basins. Magnetometers detect variations in the Earth's magnetic field, allowing scientists to map the geology of the rock hidden beneath the ice. Together, these technologies are painting the first comprehensive picture of this lost continent. This technological quest is unfolding against a backdrop of growing geopolitical tension. The Antarctic Treaty, which has preserved the continent for science and peace for over half a century, faces an uncertain future. As the 2048 review date approaches, powerful nations are positioning themselves for a future where access to Antarctica's potential resources, be they minerals, oil, or even fresh water, could become a point of contention. The rush to build research stations and conduct surveys is not just about pure scientific discovery. It is also about establishing a presence, mapping territory, and staking a claim on the future of the last unclaimed continent on Earth. What lies beneath Antarctica's ice, therefore, is far more than just rock, water, and darkness. It is a record of our planet's deep history, a dynamic system that influences our global climate, and a potential habitat for life forms unknown to science. It is a world of movement, of hidden fire, and of profound mystery. As our technology allows us to see deeper into this frozen realm, we are realizing that its stability is intrinsically linked to our own. The secrets of Antarctica are not just Antarctica's secrets. They are our secrets, and uncovering them is one of the most important and urgent scientific endeavors of our time. The future of this great white continent, and in many ways our own, hangs in the balance.